Hello, this week we turn our little micro into a big noise. Plug this into your Spectrum and turn it into a drum kit.
We'll also be examining some of the anomalies of the government's Data Protection Act. And in America, Freff discovers why teaching robots to work in dangerous places can be an uphill struggle.
If your micro has joined the skateboard and hula hoop up in the attic, now's the time to get it down, dust it off and do something creative with it, like making music. Even the Spectrum with its limited sound facilities can make a good noise, provided you've got the right add-on. This here is the Spec Drum, which comes from Cheetah. It costs £29.95 and at the moment it's only available from Boots. It plugs into the expansion port here at the back and it does need an amplifier. You see there's no onboard speaker. Well, you've just heard one of the 11 rhythm patterns supplied as part of the software, but the fun part is building up your own patterns. To do that, I select P from this menu page here, and now I've got a choice. I can either code the beats in, one at a time along these bars, a bit academic that, or I can play it in real time, which I prefer to do. So, real time. Now, I've got 8 different drums here to play with. There's a kick, which is a bass drum, snare, tom-toms, cowbell, hi-hat and so on. And I think I'll start off with the kick, that's the sensible one. So, write that. Now, it's got 2 bars there, which it's remembered, and it keeps playing them back to me. And I can alter that if I want to, but no, I'm quite happy with it. So I think I can add a snare on top of that. Here we go. A bit messy, but never mind. I could tidy it up later on. Now, I'll add something on top of that. A bit of cowbell there. That's voice 5. Right, it'll remember that lot. I could build up more tracks if I want to. You've probably noticed that to a certain extent it's tidied up what I've done, so you don't really need to be a drummer at all to use it. In fact, it's rather like a word processor for drums. You can build up sequences as long and as complex as you like. At the moment, this is only available for the Spectrum, but they are hoping to bring out a version for the Amstrad early next year. Well, yes, thank you very much, Ringo. Many micros, of course, have got much better sound facilities than the Spectrum. Well, just have a listen to this. Believe it or not, that's a standard Commodore 64. It hasn't got any add-ons. It's running the advanced music system from Firebird software. Now, that package is a very good example of the kind of thing to look for in music software. I've been joined by Tony Sellinger of Firebird. Hello. Welcome, Tony. Now, how do you go about coding in a pattern like that?
Well, it's very, very simple, really. In the program, we have 3 parallel tracks that we can record on independently. And to enter notes onto them, you can have any length of note, or any length of rest, or in fact, any note at all, which is shown by this icon here. So I can just finish off this melody to finish off the piece that I've been programming by putting the right notes in. So let's start there. Let's have that.
Oh, I think you hear it as it goes.
We do, but we've got the wrong envelope number there. And then we put that in.
Ah, now there's a bar line. Did you put that in?
No, the computer did it automatically because we've told it that this piece is in 3/4 time, so it's put the bar line in the right place. Now we can finish this off with a nice long note and a repeat bar. Enter that. We can listen to the piece that we just played.
That's just the melody part.
That's just the melody. Now we can listen to all 3 voices together.
That's quite complicated. What can you do with that now that you've composed your piece?
Well, there are a whole range of word processor-like facilities that you can use. You can define blocks, block edit, block delete, cut and paste, all that sort of thing. And all those functions are accessed through one of 4 pull-down menus that are available all the way through the program.
Actually, visually, this is a very good package because it's got those which are clear. It's also got conventional music notation at the bottom here. But what's all this at the top?
Well, there are a certain number of icons here. This one is a bar meter device which shows you how full your memory is in each of the voices. This tells us which bar we're working on. This is our volume level, and this is our envelope.
Yes, we heard a few envelopes, didn't we there? How do you build up the envelopes?
Well, in the computer we've got 3 separate sound generators, and each of those are capable of having filters and different ADSRs put on them. So we do that in our synthesizer module. which is down here.
I see. Now, what are all these icons here?
Well, this represents the module that we were just looking at, the editor. This is the keyboard, allows you to put music in real time from the Commodore keyboard. A linker, which allows you to string together music files that you've already created to make long pieces. A printer, which you can get hard copy print out of your composition, and you can add lyrics to it at that stage. Now, here we are in the synthesizer module, and we can listen to the piece that we just wrote. Now we can see they're all playing on voice 4, on envelope 4. So let's dial up envelope 4 and have a look at what we're actually listening to. That's the shape of it. And I can change that very, very simply. Let's make it into a shorter sort of sound, a more plucked sound.
Oh yes, a bit like a banjo, isn't it?
Yeah, so it's very simple.
You make it look very easy to use. Well, actually, I have had a chance of playing with the BBC version of this, and it's not too difficult at all. My one criticism is that it always sounds, I don't know, the sound has no colour to it. It's very flat.
Well, micros will always sound like micros unless you add some extra hardware onto the back. But this is why we've added the MIDI module here, the 6th module, which allows you to connect up to a MIDI-equipped synthesizer.
So, using this, you can control a fully fledged synth?
Yes, you can.
Right, thank you very much, Tony.
You're welcome.
Well, Tony mentioned MIDI there. What's MIDI? Well, to find out, making his first appearance, here's Alan Townsend.
About 3 years ago, musical instrument manufacturers got together to decide on an interface system that would allow anybody's electronic musical instrument to connect to anyone else's. And they came up with MIDI. They chose a 5-pin DIN plug for the hardware connection, as it's both cheap and it's reliable. And information is sent one message at a time from one device to the other, and each message takes only 320 microseconds. This is a MIDI synthesizer. And if I connect it with this MIDI cable to an electronic piano, then as I play the synthesizer, you'll be able to hear the piano playing as well. I'll just turn down the synthesizer so we can now only hear the piano. So what information can we send? I think the most important is key event information, which will tell the piano which notes I'm playing and when I'm playing them. And it will also send dynamic information, which is how hard I hit each note. And rhythm units can receive that same information. This is a MIDI synthesizer module, and it doesn't have its own keyboard, so it can only be played by MIDI. And this will respond to pitch bend information, and also aftertouch, which can bring in vibrato or other effects as I press on the keyboard. So by using MIDI, up to 16 different instruments can be independently controlled because you assign each one a MIDI channel number. And this is really useful when they're to be played by a sequencer or a computer.
In the news this week, computer surveys. Why are they inaccurate? Prestel finally goes into profit. And the winner of the BP Build a Robot competition. MicroLive has discovered major inconsistencies in the way surveys are conducted for the computer industry. Apricot complained this week that a survey compiled by Wharton Information Systems gave a totally inaccurate figure of 3% for their share of the personal computer market. Whartons weren't using a representative sample of Apricot dealers because they didn't possess a list of them. Apricot is now advertising Romtech's survey, which shows it with 19.2%. But this underestimates IBM's share because it doesn't include direct sales from the manufacturer to the customer. Whartons today released new figures using a revised sample of dealers, which gave Apricot only 8% of the market. Clearly, the controversy will continue. 5 years after it went nationwide, British Telecom's public view data service Prestel is finally trading at a profit. David Musson, Prestel's head of marketing, revealed that there are now 62,000 terminals attached to the Prestel network, of which just under half are in the home. The most profitable parts of Prestel are its business services, especially those reserved for travel agents. The most popular pages are the micro-magazines like Micronet. And finally, the biannual BP Build a Robot contest took place this week. Fred reports.
This year's competition was held at the Arborfield Army Camp. Most of the machines cost under £100 to build. The 20 finalists had to produce a mechanical butler capable of collecting 2 drinks from a drinks dispenser and delivering them to 2 people. Most competitors used light beams to guide their machines, with varying degrees of success. The winning entry lacked the finesse of the traditional English butler. It didn't use a computer, but tracked the light beam with homemade digital logic. A case of shaken, not stirred? His Royal Highness the Duke of Kent presented the £1,000 prize to winners Campion School, Leamington Spa, and their robot Jeeves. They plan to use the money to build more robots. Keeping information about people is vital to businesses that trade in information, like banking and insurance. Nowadays, of course, that information is nearly always held on computer databases. Personal details can be sifted through, sorted and transmitted at the push of a return key.
But the increasing ease with which personal details can be obtained has worried groups concerned with civil liberties. What if the information is wrong and as a result you're refused maybe a bank loan or an insurance policy, possibly even a job? Well, in July 1984, the Data Protection Act was passed. Its intention is to give all of us the right to look at any information about us which is held on computer for business purposes. Companies holding data on individuals are now obliged to fill in one of these. It's a data registration form saying what they hold and why. The doors of the Data Protection Office open in 10 days' time, and companies will have until May the 11th next year to return the forms, together with the £22 registration fee, or they could face unlimited fines.
Most companies in Europe have already passed data protection legislation. Norway, for example, even has data protection police to protect the right of the individual. But the British government is less worried about individual liberties than about the blow that not passing a Data Protection Act would deal to our trade. There was a danger that unless we had an act of our own, the rest of Europe would have simply refused to send their data here to be processed.
But for many businessmen, the legislation itself is a bit of a puzzle. Stephen Barry runs a wine business in London and has to keep details of payments made by individual customers. But he believes that if those customers are registered as businesses, then they no longer count as individuals under the Act. Or do they? Then there's the problem of the 150 or so bulletin board operators in Britain. Now, a spokesman for them told MicroLive that he was extremely worried by the Act because as they held computerised details on subscribers, it seems that they are liable to register. And of course, if some of the younger operators didn't bother or maybe didn't know they had to comply, I suppose it could cost them their savings.
And Kodak have come up with something that seems to fall in between 2 categories. It's their computer-accessed microfilm machine. Kodak's system uses a computer-aided search to get to personal details which are actually stored on microfilm. Well, the Act says that information stored on photographs, like card indexes, falls outside its scope. Does that mean that users of the Kodak system have to register? It isn't clear.
Well, the man who has the unenviable task of trying to sort it all out is the Data Protection Registrar, Eric Howe. Hello, Mr. Howe. It seems almost as though there are as many exceptions as there are rules, but at least we have you here to clarify some of the queries we just heard about. Can we start with the bulletin board operators? Now, how are they going to be affected by this Act?
Well, if they keep information on their subscribers, many of their subscribers will be individuals, so therefore they would be covered by the Act. It could be that there's an exemption that bulletin board operators could apply, for example, keeping information simply for accounting purposes. There are restrictions around that exemption, but they may well be able to meet those restrictions. Or alternatively, they could possibly form a club, and then, as long as they ask the members of the club if they object to that information being held and they don't, they could get an exemption that way.
Right. Would the same sort of rulings apply for other home users who are maybe using their computers to keep records of the local Parent-Teachers Association, the Residents Association, this sort of thing?
Well, if they're keeping information simply for domestic pleasure, recreational purposes, keep Auntie's birthday, for example, on the computers, that would be exempt, so many of your viewers can relax.
That is totally personal, though, isn't it?
That is correct.
Yeah.
So if they're using information for another organisation, then the organisation itself would have to consider, was it exempt or not? If, again, it was an unincorporated members club, it could possibly claim an exemption. But if it is a registered company, for example, and, for example, churches may well be in that position of having to register, then the person who, say, kept the accounts for the parochial church council would have to be covered by the register entry of the church. So he would have to make arrangements with the church about that.
And could the operators of those systems become exempt if they got permission from all the subjects of the data that they were keeping?
Well, no, it depends on the organisations themselves. As we say, if they're an unincorporated members club, maybe a tennis club is not a registered company, for example, if they speak to their members or write to their members and say, we hold this information on a computer, do you object? And they don't object, then they would be exempt from the Act.
Right.
If someone had objected, they'd have to take his information off, of course.
Down to business for a moment. Our Mr. Barry, the wine merchant, was he right in assuming that his customers aren't considered to be individuals under the Act because they're all registered businesses, as far as he knows?
Well, if they are registered businesses, then the Act doesn't cover information about corporations, about businesses as such. But I suspect many of his customers are individuals who just run restaurants of their own, and they're not registered companies. So that would be personal information. He may again be able to claim the accounts exemption, but it may be less likely in his case than it would be in the previous one we referred to. Certainly that exemption is hedged about with many provisions which all but the very small businesses probably wouldn't want to keep.
So people like Mr. Barry and in Mr. Barry's position, would they be better to be safe than sorry and register?
I think so. Certainly at the very least he should examine the Act carefully and see if he needs to register.
Is it easy enough to deregister?
Oh yes, it's easy enough to take your register entry off. Would be a simple form.
Do you get your money back?
Oh no, I'm afraid not. No, we've done all the work for the money, so we keep the money.
Right. Going on to the combined systems, the actual equipment that is covered by the Act, how about the example that we gave of the Kodak equipment, where you've got a combination, you've got a computer being used, though it's not actually storing information?
Well, the computer we saw here was linked to a microfilm machine and automatically retrieving information from it. Kodak have been discussing this with me. We've not reached a definitive conclusion yet.
When you do, let me know, and I shall tell them. It's
Fine,
obviously
okay.
still a very grey area. Anyone with any queries, they can contact you, I gather.
Oh yes, indeed. If they'd like to contact my office at Wilmslow, we distribute books like this, for example, or contact their trade association or professional body, they should be able to help.
Right, thank you very much. And full address for that, of course, will be on our programme notes. Well, I don't know whether it'll be confused data users or curious data subjects. Either way, I think your office and staff are going to be inundated, but thanks for joining us today.
Thank you, very
Thank
welcome.
you.
People in the borough of Middletown, there has been an accident at 3 Mile Island. All pregnant women and preschool children should evacuate out of a 5-mile radius.
3 Mile Island, scene of the world's worst nuclear accident. 6 years ago, the core of this reactor overheated and began to melt. It took only minutes for the core to be damaged, but the reactor will take a decade to be cleaned up. Some of the interior is still so radioactive that only machines can survive there. A lot of money has been spent on producing robot vehicles which can move around under remote control. The ultimate aim is for them to be able to navigate on their own, identify objects, and do useful work, using artificial intelligence to decide what to do. This machine is being lowered into one of the worst areas, the lower containment vessel, where the floodwater is radioactive. The vehicle just setting off to explore was one of a number developed at nearby Carnegie Mellon University in Pittsburgh. A park keeper's delight, this one keeps off the grass and stays on the path using a video camera to scan the ground ahead. Computers analyze the scene, looking for parallel lines in the machine's plane of movement. The microcomputers on board control the steering, keeping it on the path without human intervention. Because the full analysis of what it sees requires a mainframe computer to do the calculations, it must relay its pictures back by radio. From its camera, it captures a series of digitized, high-contrast images and analyzes them, looking for features, in this case, parallel lines. It then looks for changes between one image and the next, and it is those changes which make it adjust its steering. Professor Red Whitaker is in charge of the project.
But there are lots of parallel lines in the world. How does it keep them separate?
Well, in this case, it's given some cues, specifically that it looks for lines which are parallel, evenly spaced, lines that are long. And using that criterion, it could, for instance, tell the difference between a road edge and a blade of grass.
Does it ever make mistakes?
Well, certainly. Our worst foul-up, which was that this machine was following this path that we're sitting on now and traveling in that direction. It looked into the scene, took a look at a tree, and interpreted it in the following way: a pair of parallel edges that are long, that are straight, that will cast into its scene as an excellent road model. And it decided that that looked better than the path, took the tree, climbed the tree, and that was the end of that particular one. But in fact, the foul-ups are as common as the successes.
But the responsibility of letting this powerful machine loose in the real world in its present simple-minded state is a heavy one, especially for academics used to the safety of the laboratory. How would you like to meet one of these on a dark night? The inside of 3 Mile Island is a hostile one for any machine. Highly radioactive water scoured out the containment building and has left a lethal scum. Radiation levels here would be enough to give a man a lethal dose. Prolonged exposure is enough to burn out a video camera and affect circuitry on equipment which isn't properly shielded. On this unique film, we are seeing what Red Whitaker's machine saw last year inside 3 Mile Island as it moved down the now deserted corridors. A different approach to automatic navigation is being tried out back in the less hazardous corridors of Carnegie Mellon University. Instead of using vision to find its way about, this robot uses sonar, in other words, high-frequency sound waves, which are reflected back from objects in its path.
I gather that robot in the hallway has a name.
Yes, we call him Lurch.
And these are earlier versions of Lurch?
Yeah, this was the first version. This one's called Imp. And this is the one that came after that, and we call him Mobley.
Now, what does IMP stand for?
Well, IMP stands for, theoretically, Intelligent Mobile Platform.
And Mobley, what does that stand for?
Mobley stands for misspelling of mobile, I'm afraid.
Lurch scans the corridor using a ring of ultrasonic sensors, and you can see on the screen a representation of how it moves forward. The 3 parallel lines show its proposed path. As it sweeps around, it's plotting the position of walls and other objects and measuring its distance from them. If there is nothing in its way, it moves forward.
Now, why use sonar as a technique? I'm much more used to seeing things than hearing them.
People are very good at seeing things. Computers, unfortunately, are not. The problem of vision is very computationally intensive. It's difficult for computers to do it. People are working on it, but it's tricky. Sonar is good because it immediately tells you things about your environment. It tells you where you can and cannot go. So the information is immediately useful. A robot using sonar doesn't have to bump into anything because it always knows how far things are away from it.
Okay, what does it not do so well?
Well, it has a couple problems. Obviously, it sees at this level. It won't see things down here, and it won't see things up in the air. So it's possible for the robot to bump into something that it hasn't seen. It also gets fooled by things like the metal door outside our lab actually behaves like a mirror, just as people would be fooled by a room full of mirrors. Sonar can be fooled when the beams reflect off
by an acoustic mirror.
Exactly.
Well, it's all well and good to use sonar to build a picture of the walls of a room so that the robot doesn't run into them. But what happens when the robot's in the room and has to do useful work? Sonar's not good enough. How could sonar pick up this cup in the midst of all these objects and interpret what it was? You've got to use some kind of computer vision instead, and that's a much, much more difficult task. This device is being used to test an alternative approach to computer vision. It starts here, where an infrared laser diode creates a point of light, which is spread into a line by this half-cylindrical mirror. The line scans across the object and is picked up by this lens. The computer knows what angle the lens is at, what angle the light's at, and is continually triangulating as it scans along the object. It does this several times, different angles, and builds up a three-dimensional picture from its two-dimensional data. This is what the computer sees. Jerry Agan has been working on this problem for 15 years. Jerry, how does the computer sort anything meaningful out of that jumble of white lines?
Well, the idea is to build up a model in terms of features. For example, if it were looking for a flat surface, it would take a scan across in this direction, say like so, and then it would orient itself, say like this, and take another scan in a perpendicular direction. So if from two consecutive scans it finds that the surface is flat, it knows that there's a flat plane at that point.
And what does it do with that information?
Okay, that information isn't sufficient to tell, say, the difference between this and this, because they both have flat planes. So it has to go out and find more features. For example, edges, cylindrical surfaces. In the case of this object, it would scan this cylindrical surface and find that it's fairly long. In the case of this object, it would find it's fairly small. It would then have to go in and say, if it might be this and if it might be this, where should I look in order to be able to tell the difference? So it has to it'll actually go out and
search
looking
for
for that loop. Yes,
I understand.
and that will distinguish.
Of course, there's yet a further level of difficulty to the problem. Once you've gotten into the room and identified what's there, you have to deal with it in some way. Now, that's a big problem, right, Hans?
It involves integrating sensors, motion coordination, servoing to the actual manipulation. We're working on a time scale roughly 2 or 3 years on a problem that should enable one of our robots in that time to do the following. Identify a door visually.
Step one.
Servo towards the door. This is a navigation problem. With an arm extended.
Which is an engineering problem.
Yes, well, we are at the moment going to be working with a rather specialized arm, but the idea is that eventually we go to other things as well. Robot approaches door, servos hand onto doorknob.
Just like that.
Tightens hand, opens door, and then pulls back. Using, well, we have a robot with omnidirectional mobility, which makes this possible. Releases doorknob.
And walks out the door.
Well, that's the first time on MicroLive that anyone has walked out on an interview. Let's hope it's the last. Next week, we come live from Garth Hill School in Bracknell for a 3/4-hour programme, a special programme on computers in schools. And watch out, because we start slightly earlier than usual at 7:15. Until then, night.